All right, so that's the main point that we wanted to make today. Also, I just want to introduce a few special techniques. One is called an anonymous function. And then we want to point out that you can have functions that have either 0 inputs or 0 outputs. And a really special technique, this is kind of an advanced technique. How do you make a function that has a variable number of input arguments? I remember somebody asking me this in class one day. Like let's say the plot function. You can pass it different numbers of arguments. How does it keep all that straight? I'll show you how to do that. And then one more special technique that's mainly used in graphical user interface programming, global variables. All right, so what's an anonymous function? And I've never really understood the rationale for this terminology. But basically what it is, it's a single line function that's embedded within a script. So in some of the previous examples that we've had you do, you could write a function with only one line of code. And it raises the question, well, why would I go to all the trouble of making a separate function file to do one line? Well, you probably wouldn't. You probably would do that with an anonymous function. Just a way of doing a function in one line. And here's what it looks like. You put the name of the function equals the @ sign, a list of input arguments, and then any line of MATLAB code. It says expression, but it can be any line of code you want. It could be a plot command, a call to a MATLAB function, a complicated mathematical expression. Anything you can do in one line of code, you can put there. All right, so here's a really basic example. Previously, we did this example with a full function definition, but since it's only one line, it makes more sense to do it as an anonymous function. All right, so we have a function called SQR, that's the name of the function, equals, this @ just says this is an anonymous function. And then you list the arguments. And in this case, there's only one. This function only has one argument, it's called x. And then whatever you want this function to do, it's going to calculate x squared. All right, so what this does, when you call the function, you pass it a value, that will go into x. It does this operation and returns whatever this expression evaluates to, which in this case is going to be 25. And that's what will be displayed here. Or in this case, that's what A will be. All right, so just an alternate way of defining that same function that's more compact. Anonymous functions are often used in conjunction with what's called fplot, which is an alternate plotting command for specifically plotting mathematical functions. All right, so here's how you define a function using an anonymous function definition and then plot it using fplot. Okay, so we have a function called sfunct. It takes one argument called x. And what does it do? It does this calculation. And notice we got dots here. Okay, that's important because if we're going to use this for plotting, x is going to be a vector. So you need to use vector expressions here. You need to have dots. Getting a little messy. Let me erase some of that. All right. Then you can plot it with one line, fplot. You give the name of the function. This is what's called a function handle. Oops. Inconsistent delimiter there. Whenever you create an anonymous function, this name, it's really what's called a function handle, just a pointer to the function. That's what this @ does. And then you put the range of x values. Okay, that's what this is. Well, I thought I was getting better at this, maybe not so much. All right. So what do these three lines or these two lines say? They say create a function called sfunct, defined by this mathematical expression, and then plot it over the range of x values -1 to 1. And notice there's no step size given here. MATLAB will figure that out automatically. You just tell it, I want to plot this between -1 and 1, and it will figure out, based on how rapidly the function changes, what to use for the step size. Okay. All right, so instead of what we would have done before, where you set up a grid of x values using either the colon operator or linspace, and then you apply the function to that vector of x values, you just do it in one line, just saying plot this function over that range. And then you can do whatever other plotting commands you typically do, X label, Y label, title, if you want to change the axis limits. Okay. Once you've done the F plot, it's just like any other plot. You can manipulate it any way you want to. All right, this just makes the point that we always say a function has input arguments and output arguments, but actually both of those are optional. Here's an example of a function that has no input argument. Okay, you don't pass it anything, it just always does the same thing. So one example of that, it's a built-in function in MATLAB, is the clock command. You can go to the command window and type clock. And it gives you an array that's the year, month, day, hour, minute, second. It goes up to the nearest millisecond. Okay, so it took no inputs, but it gave an output. Or you can have a zero output function, a function that doesn't return anything. And the obvious example of that that you've done before is the disp command. You give it an input, which is whatever you want to print or display, but it doesn't return any outputs. All right, now here's an advanced technique. What if you want to make a function that can take variable numbers of input arguments? Like some of these statistical functions that we've done, you can apply them different ways, like the sum function. If you just do sum of x, it gives you the sum of that array. And if x is a matrix, it sums it by columns, right? But we saw that if you want to sum it by rows, you can do sum x comma 2. And this second argument means by rows instead of columns. All right, so there's a second argument that you can give it, but you don't have to. So how does it do that? And you can do the same thing with your functions. There's a built-in variable called nargin, which is the number of input arguments that were passed to the function when it was called. All right, so if you call it this way, nargin is going to be 1. If you do it this way, it equals 2. Okay. And you can have the function do different things depending on how many arguments were passed to it. So there's a code examples file that I'm not going to take the time to go over because it would be kind of time consuming, but I recommend you look at it. But I have, I think, a nice example in there of using the built-in let's see, what did I do? I think I did the arctangent. There are different arctangent functions in MATLAB depending on how you want to use it. And I did an example of combining them all, making one sort of overall function to call the appropriate version of the arctangent function from MATLAB, depending on how many arguments you give it. So I recommend you look at that example. But here's a really basic one. Let's just say we wanted to make a function to add numbers, and we can either pass it 0, 1, or 2 numbers. If we pass it 2 numbers, it adds the 2 numbers. If we only pass 1 number, then it just returns that number times 2, basically, adds it to itself. And if you call it with no arguments, then it just returns 0. Okay. So you could call this function different ways. You could do add me, whoops. Give it 2 numbers, or you could only give it 1 number. Or you can call it with no inputs at all. Just like that. Okay. I don't think we ever asked you to do this in this class, but it's just a nice technique to know for the future, to do more advanced things. Yeah, add me is the name of the function. Yeah, so that's just this particular example. The function is called add me. All right, one more. It's kind of advanced technique. Let me back up for a minute. So back here, I talked about how each function had its own variable x, all different variables. But what if you wanted them to be the same variable? What if you wanted all of these functions to be able to access the same variable x? You can do that. You make it what's called a global variable. And the way you make it a global variable is you put a declaration here, global x. Okay, that makes this variable x global, which means it can be accessed by different functions. However, any function that's going to use it has to have that same declaration, global x. All right, so the main program or script here, and then this function func2, both have this global x declaration. So they're going to share that variable. They're both going to access that same variable. Now, func1, you'll notice, does not have global x. So it has its own variable x. Okay, that's a different variable. Okay, so this is where it can get very complicated, especially when you have things in the same file, which is why I like beginners to start out doing only external functions. Okay, because when you see everything in the same file, there's a tendency to assume that the functions can all access the same variables when in fact they can't. Right? All right, so what happens here if we call func1 and we pass it the number 3? Well, that's going to go into this function's argument 3. It's argument x. All right, so x is going to be 3, and you get 9 plus 6 minus 1 is 14. Okay, just had to check my arithmetic there. Then we call func2, parentheses 1. So we're passing that value 1 into this argument. So z is 1, not x. But what's x? Well, x is still 5. Okay, this global variable has the value 5. And you might be troubled by that because you might be thinking, wait a minute, up here, x was 3. That's a different variable, okay? The local variable this function has is called, it has the value of 3. The global variable that the main program is sharing with this other function, it still has the variable 5. All right, so that's why this can be kind of a tricky technique to use. But there are times, especially with GUI programming, where it's really useful. All right, so now we have z equals 1, x equals 5. We calculate this. 2 times 1 times 5, that's 10. Minus 4 times 6, 24. Plus 2. Minus 14 plus 2, minus 12. Yeah, okay. All right, so we won't ask you to do anything with global variables until we get to graphical user interfaces in a few weeks.